بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 3.2, the product and quotient rules. We studied how to find the derivative of polynomials and the exponential function e to the power x. And here we will talk first about the product rule. And remember, the derivative of f times g is not equal to the derivative of f times the derivative of g. So you can check this rule that it is not correct if you just take, for example, the function x square. You know that f prime, the derivative of x square is 2x. While if you try to use this, if this correct, if this formula is correct, then when you find the derivative of x square, x is x times x. Okay, so the derivative of x square would be the derivative of x times x. But the derivative of x times x, according to this, the derivative of x, which is 1, times the derivative of x, which is 1, so it should be 1. So the derivative of x square, according to this rule, is 1. But we know that the derivative of x square is 2x. So this rule is not correct. And this is not correct, while this is, we are sure of this. So there is a rule, product rule, in which can be derived. And it says the most important thing for us is the rule itself to understand it. In prime notation, I like the prime notation, it's easier. So the derivative, prime means the derivative of f times g equals the function f times the derivative of g plus the function g times the derivative of f. Notice that this is product, this is multiplication. If you want to write g prime first times f, that's correct. And if you want, for example, if you want to write it f prime times g plus f times g prime, that's also the same. Okay, this is exactly this one, and this is exactly this one. Okay, I may use this most of the time. So let us take some examples. F of x, x times ex. So this is product. So what is f prime? F prime would be, I use the product rule. The derivative of x is 1 times ex. So I'm using this one, f prime times g plus x as it is times the derivative of ex, which is ex. So this is f prime. Now, if you take ex as a common factor, you will get 1 plus x. He says here, find the nth derivative of x. And remember, the nth derivative, we write it like this, f to the power parentheses and n inside them. So to find the nth derivative of this function x times ex, let us find the second derivative. So to find the second derivative, I will use this. This is the first derivative, okay? So let me use it. Let us find the derivative of the first derivative. So we get the second derivative. The derivative of ex is ex. The derivative of x times ex, again, product rule. And it will give us ex plus x ex. Okay, This is exactly this one, because the derivative of x ex, we have seen it is this one. Now, this is equal to 2ex, because we have ex plus x ex. And if you take ex as a common factor, you will have 2 plus x. Now let us try to find the third derivative. Well, to find the third derivative, we find the derivative of this one. Okay, we can use this or this or this. I'll use this one. Okay, so let us find the derivative of this. The derivative of 2ex is 2ex. And the derivative of xex is again this. This is the derivative of xex as we found in part A. 2ex plus ex would be 3ex plus xex. And if you take ex as a common factor, you will have 3 plus x. Is there a pattern here? Notice the first derivative, ex times 1 plus x, the second derivative, ex times 2 plus x, the third derivative, ex times 3 plus x. So we expect the pattern to go on. And if I ask you, what would be the nth derivative of x if you continue like this, you will say it is ex times n plus x. And that's correct. This is the nth derivative of x times ex. Another example. This is a function, differentiate. Differentiate means find the derivative. Well, I can find the derivative of this function in two ways. The first way, I can multiply our old method before studying the product rule. Multiply, expand a times square root of t, or a times t to the power half, plus b t times square root of t. Square root of t is t to the power half, and this is t to the power 1. And when we multiply, we add the powers. So we will have t to the power 1.5, or 3 over 2. So this is f of t. Let us find f prime of t. The derivative of this, as we learned in the previous section, half a times t to the power half minus 1, which is negative half, plus 3 over 2 times b to the power t times t to the power 3 over 2 minus 1, which is half. So that's the answer. If you want to write it in another way, you can write it, for example, this is a up in the numerator, and I have here 2t to the power half, okay? And here I have 3b t to the power half, or I will write it square root of t over 2. And let me write this also square root of t. T to the power half is just square root of t. I can write it like this. I can add these two fractions, but I'll stop here. That's okay. And let me now use the product rule to find the derivative of f. I have function times function. So the product rule says the derivative of the first function, which is square root of t. The derivative of square root of t is 1 over 2 times square root of t, as we have seen in the previous section, times the second function as it is, plus the first function as it is, and the derivative of the second function, derivative of a is 0, derivative of bt is b, so I will write the b here. So that's it. This is f prime. And you can prove easily that if this f prime is equal to this f prime. Let me show you that they are the same. Expand. A times 1 over 2 square root of t is this one, plus bt times this, plus b square root of t. So this is exactly this one. And when you add these two, how to add them? No need to add them. Here you have t over square root of t. This is t to the power 1. This is t to the power half. You subtract the powers. So you will get b times square root of t, because t to the power 1 minus half is half, over 2 plus b square root of t. This is half b square root of t. I can write the half here. I can take, okay. And this is 1 b square root of t. If you add the coefficients, you get half plus 1, which is 3 over 2 b square root of t. So you can see that this is exactly equal to this, and the answers are the same. Another example, this is f of x. It's a product function, square root of x times g of x. G of 4 is 2, g prime of 4 is 3, find f prime of 4. Well, this is what we need to find. So I think here, how to find f prime of 4? Well, I need f prime of x first. And then I replace x by 4 and answer the question. So how to find f prime of x? I need f of x. Well, f of x is given in the question. And it's product multiplication, product function. So I will use the product rule. The derivative of square root of x is 1 over 2 square root of x times g of x plus square root of x times the derivative of g, which is g prime of x. Well, this is f prime of x, but I need f prime of 4. Good. So I will replace x by 4. So here I will have 1 over 2 times square root of 4 times g of 4 plus square root of 4 times g prime of 4. So square root of 4 is 2, 2 times 2 is 4, so this is 4. What is g of 4? I don't have g. What is, oh, he gave it in the question. G of 4 is 2. Good. Square root of 4 is 2. G prime of 4. I don't have g. What is g prime? Oh, it is also given in the question. G prime of 4 is 3. So 2 over 4 is half plus 6. So 6.5 or 13 over 2. That's f prime of 4. Let us take now the quotient rule. The quotient means we will have quotient, function over function. Okay, so let us talk immediately about the prime notation. F over g. What is the derivative of f over g? Well, the rule says you write fraction. This is a fraction. You immediately write in the denominator g square. So that's the first thing. Write g square in the denominator. And then in the numerator, you start by the derivative of f. I also like to write it in this way. It is the same exactly, but I will write f prime first. Okay, it's multiplication, commutative. You can write it like this. So I start with the derivative of f, the numerator, times g, minus, not plus like the product rule. Now f as it is, and times the derivative of g, which is the denominator, over g square. So let us apply the rule. This is why how to find y prime. Y prime would be, I have x cubed plus 6, so I immediately write x cubed plus 6 to the power 2. This is g squared. And now, the derivative of the numerator. Let me write 3. Okay. The derivative of the numerator. What is the derivative of the numerator? 2x plus 1 times the denominator as it is minus the derivative of the denominator, okay, which is 3x squared, and the derivative of 6 is 0, times the numerator. This is the derivative, and we usually simplify the numerator. You don't do anything with the denominator, you keep it as it is. But the numerator we need to simplify because there is a minus here, so expand. 2x times x cubed is 2x to the power 4, 2x times 6, 12x, 1 times x cubed, 1 times 6 is 6, minus 3x squared times x squared is 3x to the power 4, 3x squared times x with minus sign, of course. So it would be minus 3x to the power 3. 2 plus 1 is 3. Negative 3 times negative 2 is positive 6 x squared over x to the power 3 plus 6 to the power 2. Finally, cancel or combine like terms. 2x4 minus 3x4 is negative x to the power 4. So we finished of these two. X cubed minus 3x cubed is negative 2x cubed. So we finished of these two. Plus 6x squared plus 12x plus 6 over x cubed plus 6 to the power 2. This is y prime. Find an equation of the tangent line. You remember the equation of the tangent line? It's y minus f of a equals f prime of a times x minus a. And this is a and this is f of a. So we just need to find f prime of a or y prime of a. This is y is e to the power x over 1 plus x squared. So let us find y prime. And to find y prime, I need to use the quotient rule. The quotient rule, immediately I write 1 plus x squared to the power 2. And now, the derivative of the numerator, which is e to the power x, times 1 plus x squared, the denominator, minus the derivative of the denominator, which is 2x, times the numerator, which is ex. And to simplify this, I expand the numerator as usual. Ex times 1 is ex plus x squared times ex minus 2x ex over 1 plus x squared to the power 2. I can take ex as a common factor, and I will have x squared minus 2x plus 1 over 1 plus x squared to the power 2. And actually, x squared minus 2x plus 1 is x minus 1 all square. This is a perfect square. Okay, the square root of x squared is x, the square root of 1 is 1, and the negative sign. If you raise this to the power 2, you get this one over 1 plus x squared to the power 2. And this is the simplest form of y prime. Well, I need y prime of 1 because a is 1. If I replace x by 1, 1 minus 1 would be 0. So 0 times anything is 0 over any number is 0. So y prime of 1 in this question is 0. So the equation of the tangent line would be y equals f of a, which is half e. And this is just a horizontal line. Pay attention to this note. Do not use the quotient rule every time you see a quotient. Sometimes it's easier to rewrite a quotient first to put it in a form that's simpler for differentiation. Look to this example. If you use the quotient rule here, it would be long. You will take longer time. But if you just write it as 3x squared over x plus 2 square root of x over x, and then x squared over x is x to the power 1, and x to the power half minus 1 is x to the power negative half. So this one would be written like this. And now you can find f prime easily and quickly. Derivative of 3x is 3, and the derivative of this is negative half times 2, which is negative 1, x to the power negative 3 over 2, or 3 minus 1 over x to the power 3 over 2. That's easier, much easier than using the quotient rule. So pay attention. Whenever the denominator has one term like this, you can distribute the numerator over the denominator. So here we cannot do this because we have two terms in the denominator. And here we cannot do this because we have two terms in the denominator. So as soon as you have two terms in the denominator, you realize that you have to use the quotient rule. But if there is one term like this, do this method, it's easier. These are the formulas we studied up to now. The constant of the derivative of the constant is 0. The derivative of x to the power n is n times x to the power n minus 1. Derivative of ex is ex. The derivative of CF is C times the derivative of F. The derivative of the sum is the sum of the derivatives. The derivative of the difference is the difference of the derivatives. And this is the product rule. And this is the quotient rule. Have a nice time and study hard.